Good afternoon, folks. Let's get this going. So my name is Cedric Yao. I'm a senior product manager over here at Google Cloud, specifically working with Code Assist and some of our AI SRE agents. I'm going to be joined by some friends, Afrina and Mir over there. And we are going to talk to you about some SRE agents, deploying those at scale at Google Cloud. So just one quick disclaimer. These are all forward-looking strategies. Don't hold us to anything. Let's go ahead and move forward here. So what we're going to talk a little bit about is the foundations of AI agents. I'm going to hand it over to Mir, and he's going to talk about some of the success stories that they've had at PayPal, and then we'll close you out with how we think about IDPs for deploying agents into production. So just a quick question here. I'm going to go around and ask one question. What is an AI agent to you? So hands, anybody? Let's go. Who's got an idea? Coming over here. Go ahead.
Yeah. An AI agent's just like a little robot.
A little robot. Perfect. Anybody else got an answer? All right.
Yeah. While true until condition is met.
While true. While true. So this like a deep agent kind of running. Awesome. We got another hand over here.
Persona of myself.
Persona of yourself. So like Claude Code or Gemini CLI, right? Awesome. All right. What's clear is that I need to catch my breath. What's clear is that the industry's not set on what an agent is. And we're seeing this conversation come up over and over. When I think about what an agent really is, there's really two different flavors of agents. One, an agent acting on behalf as you. The other one is this agent as an artifact, where people are deploying using libraries like ADK, Crew AI, LangGraph, various different things and tools to go do that. So what I want to talk a little bit about is the latter one. What is an agent as an artifact, and what are the effective ingredients that go into that? So when I think about this, I think at high-level abstractions, there's really three things that go into it: models, context, and tooling. And I use tooling as like this big kind of word around a concept. So when I think about models, I think about what would you do with 100 interns, right? Or 100 graduate students. You'd probably want to start to interview them, understand what do they think about, are they googly, do they fit what you're trying to do there, right? And so I think about a world where all these different models have different personalities and things that they're really good at, right? And so you want to have a place where you can effectively call any model, choose your model that is best suited for the task at hand. When we think about context engineering, it's really about taking all those graduate students and turning them into a bunch of returning interns, right? And so if you had 1,000 interns, how would you train them, or how would you teach them about the context in your organization to do the tasks that you would want them to do? I don't know about you, if I said, hey, go build this application, and I gave you 1,000 interns, how many would be really happy with me? Yes, man of my heart, right? Because they don't understand the context of the org. What are your build practices? How do you go do things in there? Should you turn this server off if it's not working, right? These are contexts that you're going to have to teach them. And so this is a critical kind of thing that I think about, with various different tools that we can help you get the right level of context into your agent itself. And the last concept I think about is tooling. This is the one that I have like air quotes around. It's a really broad topic that I think about, right? And so, again, if you've got 100 interns that are returning, how are you going to manage them, right? This is like orchestration. This could be the harness that you're using to go deploy them. This could be the platform itself that you're looking at these agents and wanting to think about how can I know that it's doing the right action? Is the tool call trajectory going in the right direction, for example? These are all questions that we try to answer here when we think about managing these specific interns. And so what I'm going to do is I'm going to hand things over to Mir, my good friend Mir, who's going to talk about how he put these three concepts into practice at PayPal.
Thank you, Cedric. Hello, everyone. My name is Mir Islam, and I lead the AI Ops and SRE at PayPal. Now, before I tell you how we did this at PayPal, let me just tell you why we had to. PayPal is one of the largest payment processors in the world. Every minute, over $5 million in revenue flows through our systems. To support this, we have 3,000 microservices. 2.5 billion API interactions happen every day. And we push 10.5 million changes in production every year. For us, failure is not an option. Our systems have to be up and running every second, every day. But this is something that no one usually talks about when they're talking about uptime, reliability, and all those things. It takes a lot of effort to keep things reliable. Our SRE and production engineers are drowning because they have to do a lot of manual repetitive work. Raise your hand if you are from SRE or production engineering. Oh, wow, okay. So I see a lot more than I expected. That is great. Now, tell me how many of you got woken up in the last 2 weeks due to an incident? So you can understand that it's very tiring, and it can be also very frustrating. We need to change how we approach our incident management. The problem at PayPal we are facing was multifaceted. We were doing repetitive manual triaging, which was draining engineers' focus. Context was getting lost between on-call shifts and incidents. Our RCA documentation and updates were getting delayed. After-hours paging was leading to engineers' burnout. 70% of our effort went into collecting data and correlating it manually during an incident. The problem is that it's not that we lacked tools, it's that we lacked orchestration. To solve the problem at PayPal, we took a bottoms-up approach. We did not start with talking about AI. We did not start talking about models. We did not even look at the frameworks. We wanted to first understand where our data was, why the data was stored, how people were accessing it, what was the connections between the data sources. And then we documented it. Our BigQuery in GCP holds most of the SRE information in the SRE data lake. Cal is our internal PayPal logging system, which provides logging, real-time observability, distributed tracing. ServiceNow holds all our ITSM, change requests. Splunk and Datadog provides logs, metrics, dashboards, alerting. One thing we did on top of this is build our SRE MCP tools. This unified API layer provided one-stop shop to access all of these disparate data sources scattered all over the place. By investing in the MCP layer, we made the agents more practical. Okay, so now let's take a look at it a little bit graphically. As you can see, there are thousands of microservices. We have various different alert generation tools, mechanisms, SaaS tools, internal tools, on-prem. We have customer interactions, information. Now imagine this. You are an SRE. You got a page, 2 a.m. Now you wake up. Now you have to traverse through this multi-data plane system. It's just mind-boggling. We had a lot of fragmented data. And even though humans, as a human, we can correlate it, it takes us time. So, what is the solution? Now, I can tell you what the solution is not first. That is, not to create more dashboards, not to create more alerts, not to create more tools. In fact, there's a 2025 report that came out that companies invested more and more in AI and toolings for operations. However, our toils did not decrease. If anything, it has increased because now we have to look at more dashboards. What is the AI doing? What is the AI tool is doing? And all the stuff, right? Solution is autonomous SRE. But this is not just another AI chatbot. This is not an AI agent sitting on top of your RAG and your knowledge base and just answering questions. This is an entire agentic workflow where the agents will detect, triage, mitigate, and report the entire lifecycle of incident. It will do it in parallel when needed and serially when required. Now let me break down what this platform actually does. First, parallel execution. Typically, traditionally, incident response is serial. You detect something, somebody wakes up, triages it, communicates it, goes back to sleep. By doing this whole process parallelly, we can speed up things. We can collapse the whole life cycle quite a bit. Second thing, persistent memory. This is actually huge. When your on-call engineers are rotating off the shift, the context that they have gathered usually goes with them, no matter how well they have documented everything. Our agents provide cross-section recall. They remember previous incidents. They remember previous user context during the shifts and take action. Third, intelligent triaging. The triaging agent is a semantic matching against our historical data. It scores the new incident and then provides the most likely root cause even before the engineer wakes up. Again, the MCP integration. This is big. All the agents will have access to our tools via the MCP. And all of these things running on GCP Vertex AI engine, serverless, auto-scale, in the managed infrastructure, with observability first in mind. Now, I want to address the key concern. Usually when I'm talking about agents, people will come and ask, okay, Mir, what model are you using? The fact of the matter is, I always try out the newest model that's out there, but your use case will actually dictate which model you are going to use. And that means you have to have a flexible system to try out different models, understand what they're doing. Model Garden in GCP provided us over 200 plus models to try out. Our current production model, Gemini 3.1 Pro, we chose it because of its superior reasoning and incident analysis. But we can swap out the models without any code change when something new comes out. But this flexibility is not good unless we can evaluate it properly. Vertex AI also gives us the evaluation framework. In QA, we can try out all the models. It helps us to determine the accuracy, hallucination, if the model is hallucinating, latency and cost profiling, and we can also try it against a set of SRE-specific tasks and see that how it performs. Now let me talk about a little bit about the development velocity, because this is where Google's ADK really shined for us. We evaluated multiple agent frameworks. We even built a couple of those in-house. But ADK actually sped up our development time by 60 to 70%. We rolled it out with 40 to 50% less coding, and we went from POC to production in 2 to 3 weeks. Now you're thinking, Mir, this sounds too good to be true. Or what is the secret here? The secret is that most of the infrastructure type work is already built in. Like it has the built-in session and memory management, persistent context, native multi-agent supervisor routing, parallel agent execution. Now, when we are building our own orchestrator, we had to think about all of those things. Now we don't. And all of these are running on an auto-scaled environment in Vertex AI with built-in monitoring. Now, let's take a look at PayPal's ecosystem a little bit. On the first two boxes or two rows, you can see that PayPal has monitoring, on-prem services, or data lake, customer interaction data, our deterministic workflow, orchestration mechanisms, and then telemetry and the microservice and so on and so forth. In the bottom layer, you can see our SRE supervisor agent. This agent is the one that actually brings in all the agents together, like our incident detection, communication, triaging, mitigation agents. Now, I want to highlight something before I move on from this. In the next conference or many other conferences, people talk about agentic workflow, and they show a nice demo. It's all good. But usually, those are in greenfield scenario. They have started a new project. They have a new data store. They have a new microservice. They can all connect it together, have the agent working together. Good. It works. But that was not the reality for us. The reality for us was we have 3,000 microservices. We have data in the GCP BigQuery. We have on-prem services. We have multiple alerting mechanisms. And our system that we built newly had to work in that reality. Let me talk a little bit about going to production. Building agents is the big part, but it mostly is easy in the sense that we have framework to build with it. But going to production is hard. But fortunately for us, Google Platform also gave us operational tools out of the box for day 2 operations. Observability, monitoring, it was already built in. Continuous evaluation and scaling and reliability, it all came in together. And top of that, we could collect the knowledge and retrain our agents so that they could work quickly. Now, I want to show a little bit of demo. I wanted to do it live, but due to some logistical reasons, we cannot run it live. So we will oops. Let me try it again. Can we go back to the previous slide? Okay, we got it up, I think. Now it's going to the next one. Okay, let's see. Okay, there you go. Yeah, I think it's working. Okay, sorry about that. Slight technical difficulty. Now, what you are seeing in the screen, on the left-hand side is our game day toolkit. That is a chaos engineering tool which we use to inject anomalies into our systems. On the right-hand side, you can see our Slack channel. What will happen is that now that we have replayed some of the anomalies, our Datadog monitoring will pick it up. And once the alerts passes a certain threshold, a message will get triggered, and it will go to the Slack channel. So it is still working on it in the background, so it is going to come up in a second. So now we can see that the message is the alert is showing up on the left-hand side, and now you see that there is a Slack message on the right-hand side, right? And what will happen is that once this message comes in, the supervisor agent will pick it up, and it's going to start doing the work. It has started a couple of agents, like investigator agent and data collector agent. Data collector agent is the one that collects data from all of the different places in different sources around PayPal. And once it collects the data, it sends it to the service analyst agent. The job of service analyst agent is to figure out what are the upstream services, what are the downstream services, what is the blast radius for this anomaly. And it collects all that information, and then it sends it to another agent called change analyst agent. Change analyst agent's job is to take all this information and see that if there is a change that was rolled out in production within this time frame that may have caused this issue. Once it has determined that, it's going to send this information to the mitigator agent. The job of mitigator's agent is to see that if that particular service has some SOP, ITR, that matches with this particular anomaly. And once it finds it, it is going to execute a task. In this particular case, in our console, you can see that what will happen is that the mitigator agent is going to restart the service. And see, you can see on the left-hand side, it says in progress. So that means that it was successfully able to restart this test service in the production. Now, once the mitigation is done, it's going to collect all the information. Reporting agent will come. It will generate a report, and then hand it off to the communications agent. Communications agent's job is to figure out who to send to for this incident, maybe to the exec, maybe to the other customer, and then close the incident. So I'll leave you with this. The future of SRE is autonomous. But that doesn't mean that it's going to come up and take our job. But what it will do is take all the repetitive tasks that we have been doing so that you and we don't have to wake up at 2 a.m. in the morning and attend a call and say, oh, if it's a false alert, it's a real alert or something, and then go back to sleep. Now, Afrina will come and talk to us how to build these agents.
Thank you, Mir. Okay. Hello, everyone. My name is Afrina, and I'm an outbound product manager here. So now Mir spoke to us about building one agent, right? Now imagine next year, 2026 or 2027, actually even today, for a lot of us, we have so many agents that's running in our enterprise world, if not personal world too, right? If all of these agents are running, now my mental mind map about thinking about these agents is, they are my returning interns, right? How do I know that these interns are capable of doing what we created them for, and how do we kind of manage them, right? So I'm going to be spending the next 10 minutes real quick to talk about how do we deploy an agent responsibly, highlighting, bold. The only thing that I want to talk about is responsibly in production. So managing 1,000 agents, right? Now think about them, like I said, a returning agent. If you are a new employee for a company, what are the things that you would have to do when you onboard? Number one, an onboarding process, right? You would have to undergo an onboarding process. Nobody's going to hand over the keys and say, now you can roam around the company, do anything that you want to. That's not going to happen. Number two, you would have a building security where you have key card access. You're going to badge in, you're going to badge out, and there's also going to be restricted area within your company. Not every single visitor can go in the restricted area, so there's going to be a clear division. Number three is an org chart. Now, all of a sudden, you have 1,000 agents running, 10,000, 20,000 agents. You want to know why an agent or an intern was pinned up. What is the purpose? What are they doing? Who are they talking to, right? Or what are they doing? Like, you need to have visibility of everything this person is doing, just like how we get monitored in an enterprise setting. And lastly, timesheet and performance, right? We have performance at Google. We call it the grad reviews. That's where we get assessed for what we do. And we also have to do the same thing for an agent, right? You got to know how the agent is making decisions. If it's hallucinating, you should almost be certain that it's going to make a mistake. But as humans, it's our ability to catch when it makes mistakes, right? So how do we do all of this? That's when we introduce the whole concept of agent governance. Now, there are really 4 pillars in agent governance. Agent security, map this with your badge, right? You need to have security access. Agent gateway, match this with the entry, the onboarding process. Like when you enter your building, think about this. Okay, if you don't know that you're entering here, what would happen? Or if you don't have access to a restricted area, you should not be entering. 3, identity and registry. All your internal org chart, right? Team chart is exactly identity and registry for agents. And lastly, observability, which is the grad performance or your performance within company. Think of the same thing for agents, where you get to see if the agent is hallucinating or making good choices or making bad choices, everything. So agent governance is the core pillar that we have to figure out if you're going to scale to tens and thousands of agents. Now, but the market is overloaded with choices, and this entire process is so exhausting. Like when you start building an agent today, imagine as a developer or any agent builder, not just a developer, anybody can build agents, right? The number of choices that you have to make. Let's start with the IDE. Then you go pick the framework, then you go pick the orchestrator, then you go pick, okay, what evals do you want to use, and then you pick skills. In Mir's example, he chose one platform that helped him, that brought everything in one place. It was easier. But that's not the case for most of us, right? We tend to go pick and choose. We like to do shopping everywhere. Now, when you're building something and you have to make so many choices, now imagine deploying them, and again, you have to make a million choices. I get decision fatigue, and I'm guessing it's the same for all of us. But really, the problem in the enterprise world is if all of us make different choices to go deploy our agents, it's a massive PR nightmare. It's a massive security nightmare. Imagine the amount of things that you cannot control inside your enterprise world, right? So what do you do? How do you deploy things securely? Now, a lot of us tend to choose non-standardized path. What we do is we try to configure all of those agent governance pieces by ClickOps, right? Nowhere on the internet you would see ClickOps is the right way to engineer things. And next, we also forget that we need visibility. Observability has always been an afterthought. We don't tend to think that, oh, I need to know, I need to go figure out traces, I need to be able to track through, I need to be able to ensure that there is a runtime protection, I need to ensure that toxic content is blocked away. We don't think about that ahead of time. And we also don't figure out how do we go see, like a lot of conversations that I've had in these 2 days, hey, we have 3,000 agents, how do we go see them? How do we manage them? Okay. So our simple solution is that you need a golden path. A golden path, to be honest, is the most simple, boring path, which is going to make deployment of your agent so standardized that it's going to be one click out of the box and you're done. And now, how do we do golden path? So when you architect for a golden path, if you think about the previous slide where I said you're building an agent and then you're deploying an agent, right? So you want to think about all the components that would not go into building an agent. For example, everything within the governance, the 4 pillars that I spoke about, a developer or an agent builder shouldn't have to configure this because they are same regardless of the type of agent that you build. If you build an autonomous agent, you need the same security, governance, and everything. If you build a marketing agent, if you build a business processing agent, regardless of the type of agent that you build, you have to implement governance regardless, right? So in that case, what you do is you take all of that, a burden from the developer or the agent builder, and put it under the platform. How do we do it? There's three simple steps to creating a golden path. Step number one, you choose your runtimes, right? There are so many runtime options available. Pick one. Pick one that fits your enterprise needs. Pick one that fits your business needs. Step two, the most important step, this is where we create the golden path. It's creating these infrastructure deployment templates and embedding agent governance inside the template. This is a one-time activity, and once you do this, step three is when you give these templates to people that are building agents within your company. You give it to them, and they are able to rinse and repeat and use the same template to go deploy how many of our agents you want. Now, by doing this, what do you get? You get out-of-box visibility. As soon as you deploy your agents, your minions everywhere, you're able to see, you are able to have full control over what they're doing, how they're doing, visibility, runtime attacks, anything that you want to go address to your SecOps team, governance team, compliance team. Now you get it right out of the box. The infrastructure orchestrator that I was referring is called Application Design Center. It's a GCP native tool. So who would go to the Application Design Center? First, we say SecOps and platform engineers or the SREs. Please go in and start creating what a deployment template would look like for your infra, right? Once you create that, then you go hand it over to your developer and be like, developer, everything from governance, security, identity gateway is pre-configured. All you have to do is push the agent logic, and you're good to go. You're no longer being the showstopper for an agent to go into production. Instead, you have created a simple golden path, ridiculously very boring path for anybody that's building an agent within your company to help them push into production. Now, the core capabilities of Application Design Center, you could have multiple deployment architecture. Like you're going to have a marketing intern, an SRE intern. You're going to have several returning interns, right? So based on the type or based on the need, you as an SRE and platform engineering team would create several architecture templates. And then you manage policies right there. Like you would say what accesses these interns would have, who they can talk to, who they cannot talk to. You control all of that right within the gateway and right inside the template. So you're not relying really on the agent builder to take care of all the non-functional requirements. And lastly, it's going to be a self-service portal, so you're really not being a bottleneck. Now, who should use ADC? Again, an architect, platform engineer, SecOps, and developer. Essentially, anybody that's building an agent and anybody that wants to deploy. This is an enterprise way of building and deploying agents at scale. Now, by doing this, anyone can deploy thousands of governed agents easily. Operators, most SREs in the room, can manage all of them easily. Most importantly, all of us can have good night's sleep. I don't want you all to sleep because we have a concert that's going to come. With that, thank you so much for staying here at 4:30 in the evening, and we can take any questions outside. Thank you.